This is the first session on implementing energy efficient data centers. This session will be taken by Mr. Amod Ranade. He is General Manager for Data Center Business Development at Schneider Electric. He focuses on business development of the data center portfolio offerings from Schneider Electric, and he has previously held rich product management and program management position for site and facility services at IBM India. He was involved in driving various programs for data center infrastructure services offerings in various stages of the data center infrastructure cycle. Amod comes with a strong background in data center technologies, particularly with reference to power, cooling, and management software. And he has held product management positions in APC by Schneider Electric for data center solutions. He has also managed data center related product lines like racks, power distribution systems, high density cooling systems, etc. The early part of his career, he was involved in the channel management and regional sales for IT products and UPS systems. Amod is an MBA and an engineering graduate from the University of Pune. So please welcome Mr. Amod Ranade to the stage.
Thank you. So thank you for that kind introduction and welcome. Thank you for taking time out from your busy schedules to be a part of this session. What I will focus on in the next 30-35 minutes is I will share with you the extract of one of our white papers. There are a huge amount of white papers that you can look for. Just you go to the websites which I will indicate to you later. So I will how to implement energy efficient data centers is going to be the topic that I will try to share my learnings and findings with you. Wherever we talk about performance, and especially from data centers, there is nothing more ambiguous or there is nothing more confusing that we can actually try to get our hands into. Because when we talk about data centers and the data center performance, and then coming down to a metric like an efficiency, there are so many things that we can choose from. So there have been a lot of attempts to try and create a new standard for measuring the performance and efficiency of a data center with respect to the CPU utilization, with respect to virtualization percentage, with respect to space optimization, and so on and so forth. But we believe that these kind of metrics will only work if they are unambiguous. And the most unambiguous metric that one can focus on from a data center perspective is energy cost. Because no way you are going to escape from that electricity bill which will hit you as a cost in your costs, right? Every month, month on month. We are also seeing a trend wherein this particular cost is actually on the increase. Not from just the consumption perspective, which also is an increase, but also from the rate perspective as well. So we know that electricity is only going to get more expensive in India. We have implemented a lot of these best practices in data centers, and we are very strong believers that it is possible to dramatically reduce this energy consumption in data centers worldwide. How big is this a hit? If I just start focusing on the efficiency of a data center and I'm taking the metric of only energy, how expensive can it get? What you see is approximately the average cost of electricity in the US, 12 cents, and which translates to approximately $1,000 on energy cost for a year for every kilowatt of IT that you are going to power, right? Per kilowatt, $1,000 does sound steep, right? But actually in India, this will translate to more like $2,000 to $2,500 per kilowatt. And the main reason for that is that electricity is more expensive in India than in the US. So it is nowhere close to 12 cents that I am talking about. It is more than double of that when you look at average electricity cost that we need to pay in India. So if we are already seeing a lot of movement happening around energy efficiency globally, especially in the developed countries like the US and Europe, we should be actually taking it to the market at double the pace, right? Because we are hit twice than what the other countries are hit. Where does all this energy go? So what I am showing you is a typical data center. Globally, it is an acknowledged fact that data centers are less than 50% efficient, right? And the way data center efficiency is measured from an energy perspective is PUE. How many of you here know what a PUE is? Okay, so just one hand went up, so I hope the others are not raising hand just because they are asleep. So PUE is power utilization effectiveness. It is nothing but a ratio. It's a ratio between the total power that you feed a data center divided by the total power that is actually consumed by IT. Right? Now many of you will want to question me, why don't I do the inverse of it, right? Because then I get a nice percentage figure and then it is much easier to understand. But we have seen globally that DCIE, as it was called, or data center infrastructure efficiency, which was in percentages, there were not many takers for it, unfortunately, right? So the slightly complex metric called PUE is more prevalent today. So looking at the nature of its definition, a PUE can go from best case of 1, wherein nothing is consumed other than the IT equipment, to going as high as infinity, right? So that's the range that we can talk about. So just because we have a PUE of 2 and another with a PUE of 3, we definitely know that the PUE of 3 is worse as compared to the PUE of 2. We also have acknowledged globally that PUEs typically range between 2 to 2.5 globally, right? And this is impacted in a big way by the outside climate. So why is that? So the figure answer is on the screen. Cooling equipment consume the biggest chunk of power in a data center infrastructure. So here I am talking about chillers, I am talking about humidifiers and air handling units. The chiller can simply get replaced with what I can call as a compressor if you are using a completely refrigerant based system. But the energy consumption, unfortunately, is in the same pattern, right? So almost double of it is on air conditioning, and air conditioning energy will directly depend upon how much effort you need to take to remove that heat out. So if we have a tropical climate like the one that we have in India, where it does get pretty hot out there, we'll have to put more energy into our compressors to pump that heat out. So obviously, if I have an equal running efficient data center, one in India and one in Colorado, just because the Colorado will show an efficiency of PUE of 2 and we will be showing a PUE of 2.2, we may actually be better off than the Colorado data center, right? So we need to be very careful how we use that PUE as a metric. So it is not an absolute metric. It's a metric which will depend from climate to climate conditions. It will also depend on the kind of densities that you are deploying in your data center and so on and so forth. So where do we begin? This is where the energy goes. So clearly, we should start with the biggest first, right? The biggest is right in the center, IT itself. There are a lot of technologies which are becoming commonplace today, like virtualization, which are a great tool for improving your asset utilization from a CPU perspective. The same, when applied to storage, can also result in huge amount of savings with respect to utilizing virtualized storage and other methodologies. Next, we should go at least to the cooling. Third, we should not forget the power conditioning as well as distribution. That is where a measly 10% of typical data centers really goes. When I want to focus on energy reduction, where should I focus? There are two ways of looking at energy reduction program in itself. So if you are running data centers, which I am sure you are, there are two ways that you can attack that problem. One is what is called as a temporary avoidance, which means doing very small things on and off, which are helping you save some energy in your data center. Something as simple as you walk into the data center and you know that there was nobody in there and nobody is expected to be there and all the lights are on, so you switch it off. Temporary avoidance, right? Second is what we call as a structural avoidance program, wherein we put that strategy of energy avoidance as a plan. It is designed into your data center infrastructure. So how can I do that? First example would be to make a data center infrastructure modular, so that when you know that your data center is only loaded to up to 40% of IT load, you should be able to shut down certain modules, for example UPS systems, for example chillers, etc., which anyway you don't require because of the capacity, right? So this is what is called as a structural avoidance. So structurally your data center is capable of modulating its capacity to meet the requirement posed by IT equipment and thus helping you make it more efficient. How much can we save? Looking at the temporary avoidance methodology or looking at a structural avoidance methodology? Very clearly, the biggest impact that you will have, and which is almost 4 times the impact, is in structural avoidance rather than temporary avoidance. Because with temporary avoidance, first, it is very difficult to implement in a programmed manner. Because otherwise you need to increase your manpower itself to just keep on focusing on where can I save some energy, right? Or the second way of doing it is in a more programmed fashion, which is the structural avoidance methodology, where you already take into factor all the things that can happen during an operating condition of a data center, and you have planned certain things in your technology, in your operation, in your maintenance, so that your energy reduces. There are 2 ways in which you can take care of the structural avoidance itself, right? First is operational, and second is planning. Which is more important? If you ask me, I would prefer to tell you that operational is more critical with respect to actual deployment and getting the actual benefit of energy reduction from your data centers. Because at the planning stage, you can plan a lot of things, right? But whichever data center you want to create today, which is expected to last you for a decade at least, because it's a capital intensive kind of an investment, there is no way you can predict very accurately what is going to come in the future, right? Almost every few months we are seeing something new coming in from an IT as a tool for you to leverage to try and make your IT layer more efficient, and then you have to react with the infrastructure to meet that kind of a challenge. So there is always going to be a gap between what you plan and what actually exists in a data center. And that is where how you operate that data center, which is already deployed, becomes much more critical. What can we do from an operational perspective that can really help us with respect to our energy consumptions in data centers? First is retiring IT systems, right? Now I know not many have the luxury to throw out perfectly working IT systems, right? But we always need to keep in mind that a particular IT, just because it is working, may not be a good reason why it should not get retired. So what we need to look at is we need to benchmark these old IT systems, which may be working fine, but benchmark it with an equivalent current model of IT, and then make an ROI analysis that, okay, if I actually retire this system, it would be 5-6 years old, I get in a new system, its replacement, what kind of an impact can I have from an energy perspective and from the architecture perspective itself? Because whenever we talk about virtualization, many times I have seen data center projects on virtualization getting into a halt mode, because suddenly they discover that, oh, the servers which you are using are a bit too old, so we can't really leverage it to the fullest for virtualization, and so on and so forth, right? So from that perspective also, it may make sense many times to actually retire some of the old IT systems. Second is operating the systems in an efficient manner. And there is a big chunk of this which actually comes from the way we manually do things in our data center. Just because you would have evaluated and bought the most efficient component does not guarantee that it is going to be serving you in the most efficient way, because how you use that component is very critical in ensuring that you get the benefit that it was intended to bring in. So we need to look at monitoring of asset utilization, we need to look at monitoring of space, we need to look at monitoring of energy, and so on, because only when you monitor can you compare it with any benchmark, right? And so operating ensure the system to the fullest, that efficiency is maximum. Migrating efficiency, this is which I don't want to go into here. Will be able to take my talking about technologies, right? That today which every with what be very careful technology do your peer and so that and presenting to case why you flip the correct matter worth of period you have been given by finance department, the protocol, it will challenge that we have look at possible bring customers who start the application saying, okay, I have read, I know virtualization, I can achieve a ratio of replication servers with one server. Based on that, which looks very attractive. But when you look at implementing an application in particular IT, suddenly we are able to 3 or not 10, right? And that is again something to work with. When we talk about virtualization, what we get many times is that there is an underlying principle which concept of virtualization, and that is the concept of virtualization. So is a lot that you want to deploy using etc. But step, right? I'm sure of you, if many of you will stagnation is reduces your negotiation. I know of customers where they have shared with me open. See, in my data center, I have of IT infrastructure. I have vendors. He feels that that's a lot of negotiation power with because he has money. Because the vendors that dependent on this customer. Members of it also feel where to go to extreme when we talk about IT. To give you a rough example, as a customer know they have a large data set in Denmark. What the day today to buy print, for example, all the different vendors, right? So let's there are lot one vendor X is printers. In fact, in one line, in company demand is only then the, and I want to deliver from the model, one vendor, one, because now in the operating methodologies, any at the manufacturing stage it's replicate. For example, they connect that somewhere and suddenly that centers get of them are going to do instead of get the corrected deployed. So has with respect to overall efficiency. What next? In case customer to a virtualized platform, that of total height using it has actually so there was no benefit increasing the moment and the is consuming more it is for so looking at had 100 and because 20 then the infrastructure delivery way 30 racks which is not there, otherwise all of these are on as if it was all of them are consuming the air is and so on. The ability of the data center infrastructure match the IT is crucial in data centers. So the cycle of okay, reduce IT, you need to go back and size infrastructure the efficiency benefit. And is using efficient. Again, here equipment to buy infrastructure perspective to be on running here, right? of them will tell you years. Easily they will keep on working, keep maintaining them properly. Will keep on working for 20, 30 years, as and when they we need to, from perspective, technological advances that take place in replacing 10-year-old or system, especially by implementing efficient, which is many times what also becomes here, when you go back, when you design data center, expected, let's say 500 kVA of need in the next, and we gone, still our kVA becomes an opportunity that with a more is that system that again gather better benefits. And third, an efficient. Now, why would I say we should design efficiently? Because we are inefficient, and for that is redundancy. Expect high reliability from the infrastructure center. Everything depends on server running and. So I know that many mechanical can fail. So I will replace them. And then there's this. So we said we have 4 tiers. We took those tiers, those kind of tiers. More details. What should you put? Transfer, redundant, so on and so forth. Higher back just every tier 4 data center. Tier 4 center, which means your more digisets, more piping, all of that hit you. To make business decision of redundancy, do you, because that is how you are going to design a system. Factor. So right sizing so much, because look at any code, there is always curve, or there are always 2 types of loss. Then that loss. Third, when you are using it, purpose, it will happen. For example, you talk, there is an example. The variable losses will on that 100 kV load. It is and so on. And this is true. When talk about children, right? This is true. And more able to go actually load onto the device. From UPS system, we know at least basic. So we have 2 active for up server SMPs where UPS cannot go above 50% load. So you not just will talk up to 57% UPS, right? You at how much efficient? 40%. 50 is the your UPS will right? So we be kind of efficient. Benefits can we get? Up cost go up, right? Firstly, buy so capital you and operate because it's loaded more. Cost, right? You buy, pay for KVA maintenance. You may be use profit, but if you go architect benefits, you can get up to half. And I'm talking about of technology, new being achieved. Right? Never before efficiencies are. I still remember years back there was a paper which I read when it was mathematically proved that you can't do more than efficiency anyway. And you are there, so everybody was very. Double conversion, it is percent efficiency. Advances which and that your job because something more efficient does not mean it for you. This is where you are to take business decision an IT to share the because of improvement identified in the same then you should look at efficient component bad but museum more critical. So the combination of efficient designed together as a you say that which is talking about a model, let's say modular and so on. Your facility 600 better performance, not really. So it should be throughout. So the cool distance space we thought of as buying more to get that kind of a itself. So respect to that fresh is a very good idea, but right is that every you need many times that can happen in a require is talking about flow around the AC is method both heating are you so can be efficiency improvement like what the can to temp so right to see so what you what is the come back. Now the looking at, so you should idea of come back, come and up beyond that he has put. So that it using said, you know, you have motion sensors on lights and stuff like that. Let me tell you, it actually I don't like that technology much personally, right? Because when I sit in my office, there is a motion sensor based light there, it switches off the moment I stop moving. So in a data center, if you are working and you are motionless for some time, you are reading something on a screen, the light will switch off. So instead of that, why not have very simple methods of light control of electricity, switch on, switch off, right? Let's have it at a place which is very easily accessible. Because another thing which I have seen, you enter a data center through its door, you will not find many switches around anyway. So as a user, if you want to make use of this, that okay, when I'm going out, I'll switch off and go, you can't. So small things that can be done which can result in decent amount of energy savings. By right sizing, up to 30% energy savings are possible. By virtualization, up to 40% are possible. Again, best case may be 40%, best case may be 70%. But for your particular infrastructure, it could be at a 10-15% as well. But why not make use of it? More efficient air conditioning architectures increase the set points, right? So typically, it should always be more than 25-26 degrees Celsius your set point, ideally speaking. Again, you need to be ensuring that there is no short circuit paths in your data center which have got created, etc. Because otherwise, by trying this improvement methodology, you may start getting alarms on some IT equipment. So we need to solve that airflow problem first, then target the set point problem, and then we are very easily you can increase set point temperatures even up to 27-28 degrees Celsius. Economizer modes, more efficient layouts. Many times I see, there is a big floor and there are a group of racks here in this corner and there are a few racks there in that corner, right? Why not move them together, stack them together so that maybe all the other ACs which are far away can be switched off. Otherwise, if you have two corners where only 2 and 2 racks or 4 racks are there, you need to run all the ACs which are around this place and so on. So space, layout, etc. also can be very important in reducing energy consumption. Coordination itself can get you up to 10% benefits from air conditioners. Tiles placement. Many times I have seen even hotels having tiles, right? So we need to bring in a discipline where we identify and we accept the fact that in data center there will be some region which is expected to be cold and there is some region which is expected to be hot, which is the backside of the racks, right? By not doing that, we are unnecessarily mixing hot and cold air, and which is again going to hit us in the reduction of overall efficiency of our data center. Lighting, 1-3% kind of benefits are possible. Blanking panels, 1-2% are possible. There are so many things that can be done in a data center from an efficiency perspective, right? And like I was telling you, oh, you need to analyze, and you will say that, okay, do I need to build a team tomorrow? Go to the CFO, I need a 5-member team, I am going to do a lot of analysis on all the UPS technologies, all the chiller technologies and so on. Not really, right? So what you would actually like, we feel, is that you show me a benchmark case study, at least at a high level, let me see what works, what doesn't work. And from that I will choose something which I can go more into deep, right? So there are a lot of tools like these which are available, which we call as trade-off tools, because trade-off is always there because higher efficiency, lower OPEX, higher cost, lower cost. So right, there is always going to be a midpoint where it is not too expensive and it is bringing you good returns. So this kind of analysis always helps. So there are a lot of tools. You can just go on tools.apc.com, it's a website. And there are a lot of tools which can help you estimate that, okay, if I increase the temperature in my data center by 2 degrees Celsius, how much energy can I reduce? These kind of configurators are there with live modeling, which can actually help you in making that decision that, okay, should I take this action or should I not, at a very initial level, so that you don't end up analyzing a lot, which can only get you a degree maybe, but not much use in the business. I talked about a lot of things, we can do this, we can do that, up to 30% savings as possible, etc. I also told you that it is very dependent upon the outside climate. So many of us, they look at Schneider Electric and they say, oh, this is a European company, so you must be talking about savings in Europe, right? Not really. All the savings that I was talking to you about are implemented and available in India. A case study in point is this data center. It's approximately a 1 megawatt data center design, wherein first phase, it was modularly built, first phase of half, that was built, 500 kilowatts. The client wanted an architecture which could last 10 years, and they wanted to bring in all the efficiency benefits and so on. So right from space, optimized, efficiency of UPS system optimized, modularity in design, high efficiency cooling systems deployed which can control high density equipment as well as low consumption of energy and so on and so forth. So by doing this, they were able to see up to 30% of reduction from the earlier data centers that they were using. Simple benefit is PUE, right? We also were able to implement to them a dashboard, a live dashboard of PUE itself, right? Because what you cannot monitor, you cannot manage. So unless you have access to information like PUE for your own data center, there is no way you are going to be able to discuss and argue with anybody in your organization that why it needs improvement. What is invisible is already improved, right? So real-time PUE view is not very difficult to get. And again, it doesn't have to be with very fancy softwares. There are BMS systems possible today where maybe you are already using one, where a simple add-on can get you a PUE view. But it is critical for you to start demanding that, because only when you demand, you will get. And then that will become the first benchmarking point to compare yourself with other data centers in your own region. To conclude, the cost of electricity is very substantial. Just the energy cost of a data center in its life cycle is almost 70% of the total cost. And it is going to be definitely 70% the rate at which the electricity cost is increasing, right? Second, any approach for reducing energy is a good approach. What you need to do, measure your current performance, take up one task at a time and see the benefits that you are getting. The other benefit that you will get is because you will be having so much data with you, the next time you go to your CFO for more funds for an energy implementation, he will listen to you because he knows that, okay, you had asked for a very small amount earlier and you actually delivered the efficiency benefits, which he is seeing in his OPEX, right? The third is cost saving opportunities are very large. We are talking about data centers in India where it is much beyond 3. The reason people are not scared about it is because they don't know. Sometimes when we end up doing an audit for data center, etc., we suddenly find out that have we calculated something wrong because the PU is coming 3.6, right? And that is when everybody gets woken up that, hey, there's a lot that can be done. So let us start with humble beginnings. I challenge you all to go and get yourself the PUE for your own data center. Start focusing on airflow management, start focusing on set point improvements, etc. If you need any help, you can always reach out to us. There is a huge amount of white papers which are available on our websites. So if you want to just delve into what kind of technologies today are we talking about with chillers, with UPS systems, with building management systems, with DCIM, etc., feel free to browse. Thank you. Do we have time for some questions? Okay. Yeah.
I'm Suresh from Bangalore International Airport.
Hi.
Actually, in right sizing the DCPI, how do we start off? Like basically, we would have different systems and servers with a rated power load. Now, do we take that into account and then do the right sizing, or do we take, say, based on our earlier usage pattern? Do we take that data and then do the sizing? Because if we take the rated power, then you would obviously be building it to maybe double the size or maybe.
Yeah, that's true. So there are actually three ways of how we can look at how to right size from a planning perspective, and these three ways are different because of the way the scenario can be different for a particular data center owner. For example, if you already have a lot of data centers and you are looking at consolidating them, right? Then getting data of actual consumption of servers is going to be easier for you. So in that case, I will recommend you have to be sizing based on actual consumption, because in your data center, you have been using it for the last 5-6 years. So if you have an enterprise management system, you can very easily get those curves of what is the energy consumption per server, what kind of CPU utilization you are getting, and so on.
But if we have not been measuring it, then it becomes.
If you have never been measuring it, it's a completely fresh greenfield kind of a project. The best way to go about it is first size according to your SMPS rating, right? But I'm not saying deploy based on SMPS rating. Size as per SMPS rating, and then based on a lot of information which is available through simulators. There are simulators available wherein if you tell them that, okay, I expect 35% CPU utilization, what kind of power will it consume? Those kind of simulated data are available from many vendors. So you use that data and marry the two together. Or there is a very commonly used thing called diversity factor. Right? So in many large data center also, when we are designing, many times this kind of a thing comes in where, okay, we add up all the capacities on an Excel sheet, whatever comes into 0.8 diversity factor, because not every system will be running at its peak at the same time, and so on and so forth. But before you get into diversity factor, you need to have a lot of domain expertise with respect to, in that particular industry, what kind of factors can I really use? Because if you are in a very compute intensive environment and you take diversity factors like this, you will end up undersizing your capacity. So there are various things that can be done, but the first thing that you should never do is don't design based on SMPS rating, because that is always going to be higher.
And the other question was about in-row cooling and closed containment in a rack itself. So which one, according to you, is better?
If you ask me, both are very good options, right? What it will also depend upon is the user expectations with respect to how he wants to service it, how much he needs to go and open the racks, and so on and so forth. The third thing is also with respect to, in data centers, for example, if I use a completely closed coupled approach, then what I actually practically do is I have a rack itself which is cooled inside, so the outside ambient doesn't really matter kind of a scenario. But in data centers, many times I have seen there are equipment which are not rack mounted. So the benefit of using an open system is where, because you are anyway cooling the entire environment, or rather you are not cooling the entire environment around is cool. So you can also take care of a lot of low density equipments which you don't need a special AC for. For example, your patch panel racks or very low density networking racks, etc. You don't actually need a special air conditioning system for that if you have an open system. With respect to one factor alone, for example, efficiency of your fans and efficiency of refrigeration itself, closed coupled will be the best. To go one step beyond, what a lot of people are actually researching, and I have actually seen a couple of products out there which are being talked about, cooling at the chip level itself, that is the extreme level of close coupling that you can do, right? So I know of servers where actually chilled water piping runs on the motherboard in copper, right? And that kind of a system works. And so from a efficiency perspective, closer the better. But many times from an operational perspective, sometimes a little open systems are more flexible. For example, there are many equipments which cannot be rack mounted. So it becomes difficult to find a close coupled for it. So if it is a half open, half closed, or more flexible, that's a choice that we have.
Finally, one question.
Good afternoon. Like in bandwidth or performance management, we can do it for the server, right? Or for the internet bandwidth, we can see the bandwidth, right? Same way, is it possible to manage or view particular watt or energy performance, or where we can see that yes, this month the wattage shows high, it is because of the specific rack. Such kind of monitoring systems are also available?
Yes. So today, if you ask me technologically speaking, per U, energy management is actually possible, technologically speaking, or per outlet. So in a rack, if you have a PDU with 12 outlets, each outlet also can be metered for energy consumption today. So, but we again need to do a trade-off, because sometimes too much data may not help, too little data anyway doesn't help. So we need to be able to find that middle path where at least we take, okay, at least per rack energy consumption I need to know, or I need to see a trend. Many times because PUE, it is so difficult, right? Because many times I've seen customers where they say new data center implemented in the month of December, and they measure PUE, and they say, oh, it is less than 2, it's a great data center. But that is only instantaneous PUE, like, so what everybody means when they say PUE is annualized PUE. So let it go 12 months, all the seasons, and then you see overall what is the PUE you have got. Because in winter you are anyway going to get good, right? So this is another factor, yes. But technologically, getting trends of your overall data center efficiency at rack level, at floor level, all is possible today. So there are a lot of technologies available which help you do that.